This video is brought to you by Iceberg. They make pretty good shakes. They take forever getting them ready, but they make pretty good shakes. Well, why am I bringing that up for this video? You ever do, oh, I know you did, have one of those math problems that you just got to eat chocolate or eat ice cream or something like that because it's just driving you nuts? Well, that probably would be something like this, okay? Working with complex fractions. So in this one, I'm going to use method 1 again to do this one. 9 over x plus 3 plus 6 over x plus 5. All that over 5x plus 21 over x squared plus 8x plus 15. So again, this is what's called a complex fraction. There are a couple ways to do these. The one that I usually recommend is method 1. People tend to like it better. There is another way to do these, and I'll show that probably in a future video. So before I go anywhere here, I'm going to take this x squared plus 8x plus 15, and that's going to factor pretty nice. And I think I have a dead marker. Let's see if this is any better. Yeah, a little bit. In a lot of times in these kinds of problems, you can look at some of these other factors in the denominator to help you figure out how this guy's going to factor. So yeah, it's going to factor to x plus 3 and x plus 5, which is kind of cool. So now, using this method 1 idea, what I'm going to do is I'm going to take this big numerator here and this big denominator here and make sure that they're both one fraction each. So what I have circled in the my big numerator, I'm going to compress it so it's one fraction, okay? My denominator's already set up, so that's kind of nice. All right, so how I'm going to do this is look at the least common denominator with these two fractions here. We're going to add these with the least common denominator. So I'm going to multiply this x plus 3 by an x plus 5. And what you do to the denominator, you do to the numerator. So I'll multiply the numerator by x plus 5 as well. As for the second fraction, I'm going to multiply that numerator and denominator by an x plus 3. All right, so here's what we're looking at. I'll write it down here. I kind of got a small board here, but hopefully this will do what I want it to. So now I've got 9 times a quantity of x plus 5 plus 6 times a quantity of x plus 3. And all that's going to be over x plus 3 and x plus 5. That's my big numerator. And downstairs I've got 5x plus 21 over x plus 3 times x plus 5. Okay? So, if we took a look at what we've got here, let me simplify this numerator within the numerator a little bit. I'll distribute and collect like terms, and let's see where that takes us here. Need to write smaller. I wrote the original problem way too big. So, distributing the 9 through. 9x plus 45. Distributing the 6 through, so plus 6x plus 18. All that over my x plus 3 and x plus 5. And that is over the 5x plus 21 and the x plus 3 and x plus 5. So cleaning it up some more, 9x and 6x is 15x. 45 and 18, let's see, what is that? 363, I believe. Yep. So all that's over my x plus 3 and x plus 5. And that's over 5x plus 21 over x plus 3 and x plus 5. Let me pause the video just for a minute. I'll erase all this stuff and move this over here so that I have more real estate to work with. Hang on. All right, I transposed it up here. Now we can work with what we've got. So method 1, what the objective there is to get one fraction divided by another fraction. Okay, that's your main objective when you use this method 1 approach. And I did that. It took some doing on that big numerator there. The big denominator was already there. But I've done that. So what's going to happen now is I'm going to invert and multiply my big denominator and multiply it to my big numerator. Some people like to call it the whole copy dot flip, where you copy the 15x plus 63 over x plus 3 and x plus 5. Then write a dot for multiplication, and then flip this guy over. So now we've got x plus 3 times x plus 5 over the 5x plus 21. Sometimes people need clarification as to, wait a minute, why did that guy flip over and multiply to the numerator? Okay, think of it this way. If you multiplied my big numerator, my big denominator by x plus 3 times x plus 5 over 5x plus 21, and what you do to the top, you do to the bottom, like that. What you do is you see the 5x plus 21 drop here, the x plus 3, and that x plus 3 divide out there, and this x plus 5 and this x plus 5 divide out there. So, and then you see that you've got your big numerator times your now inverted, formerly known as the denominator. But that took a lot of work, right? So that's logistically how that works mathematically. This is a little bit of a shortcut that'll save us this step, right? You just copy the top one and then write a dot for multiplication and then flip the bottom one. Okay, so let's see what we can get to reduce. This x plus 3 and this x plus 3 divide out. This x plus 5 and this x plus 5 divide out. And you know what? Let me write what I've got so far. 15x plus 63 over 5x plus 21. You would think that this problem is done. Check out the numerator. It has the greatest common factor. We could pull a 3 out of there. So you pull a 3 out and look what we've got. 5x plus 21. Oh, that over 5x plus 21. Those 5x plus 21s divide out. Your answer is 3. Wow. All that work to get a number as an answer. That was kind of cool. Hey, and what I tell my students sometime is I tell them this. When you get married and you have a child that's 3 years old and people ask you, how old are you, little boy or little girl? You tell them, I am 15x plus 63 over x plus 3 over times x times plus 5. You get the idea. Blah, 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 years old. And then watch their reaction and see what they say. They'll say, oh, you poor child. All right. I hope that helps you guys. I'll probably do this problem again using method 2.